think everyone can hear? Okay, I'm gonna say those yes. Okay, bye jails. Yeah. Why is broken? Come on. Oh, there we go. All right, no announcements this week. Just have a good Thanksgiving break. And here's the meeting flag. Well, you guys are typing in the talk. It's like the first time I'm ever getting a week off for Thanksgiving, so I'm pretty hyped. Yeah. It's always 3 days, but that's all. Okay, cool, it's not. So what is a jail? If there's no handcuffs, yeah, what's happening? A jail is a restricted environment in the same context as the program, with just restrictions placed either on the source. No, I'm good. Yeah, I'm just gonna move a little speaker with the text. Oh, okay, that's fine.
I also heard that.
I just hit the.
Yeah.
You're
good. Good.
Sorry. Oh my god. All right. With just some restrictions placed on your input, usually that would be like characters you can't use or words you can't use in your source code. And it's different than a sandbox, which we'll show better on the next slide. So a sandbox is usually running on a virtual machine, which doesn't have network access or read-write access. And all that's happening is it's running your code and then sending the output back to the main program. So it can't, for instance, read a file on your main computer, which is a pretty common issue with jails, where jails run in the same environment, but again, with some restrictions, which you'll see later on. Okay. It's like kind of working. It's like good enough.
Okay.
All right. So here's an example of where someone might write a jail. So for instance, this is like a teacher who wants their student to write a function that adds together two numbers. We can see in the first example, the student, not very smart, wrote a function that multiplies two numbers together. So yeah, that's incorrect. Second example, they wrote it correctly, it added the two numbers together. So yeah, it's super convenient here how you don't need to write any extra code. You literally just evaluate the source code and then you get the function. But since there's no restrictions based on what it could do, we could do this. So now we're importing OS and running os.system, which can run any shell command. Here we wrote whois, which gives us this output. But instead of running whois, we could write literally any shell command. And I think everyone here can think of some bad things you can do with shell commands. So your first question might be like, is this real? Is anyone actually doing this? Answer is yes, some people are actually doing this. So here's some examples of people who might want to do this, like LeetCode, HackerRank, HeroAway, or PrairieLearn. These are all just easier ways to implement a sandbox, which is what you should actually be implementing if you're running user-provided code. But sandboxes are hard to make correctly. They have additional overhead, as in you have to manage a VM, which might need memory, CPU usage, and all those sorts of other things. And if you're not in cybersecurity, you might just think like, no big deal, no one can actually really do anything bad here, especially if I say they can't run systems. What else are they going to do without system? It's a lot you can do without system. And yeah, jails are just simpler to implement and use. There we go. So here's what you can do without system. There are other ways to execute commands in Python. We gave like 3 here. So you could do os.popen, which just runs the command and then does .read. I'm not going to read out the other two. They all basically do the same thing. Just pay close attention here to the ones that say print and the ones that don't. Because some will just pipe the std out and give you the output, and some will actually go to a string in Python, and you need to know which one you're dealing with, because you might just get nothing, and then be like, oh, it didn't work. It did work, you just need to print. Here's some other things. For the first 3, just pay close attention. There's another exec. This isn't the same exec as it was in the server source code. This is in your source code. If you didn't include it, you would just be adding together 2 strings, for example, with the first one, which does not. So here we split system into sys and tum. So when they're checking your source code, they're looking for the string system. Doesn't occur anywhere. So like, okay, this is safe. It's not safe because after the strings get added together and it gets exec, it does the same thing as what you would have done without the space. The second one, we just encoded the entire string into hex. the same as the first one, import os.system, except now again, when you're checking the source code, string system doesn't occur anywhere, thinks it's safe, it's not. Third one is kind of cool because we're using CHR, which takes the Unicode representation in decimal and then returns that letter. So here we actually managed to build a string without ever using a single or double quote. So if that's banned, you can still create strings, you can still execute. And then finally, this last one is kind of cool and pretty useful because a lot of jail developers might not know about this. So again, okay, here we're just using special Unicode characters for the import and system. So here, when it's actually checking, it looks for the keyword system, but it doesn't occur anywhere because we're using the special Unicode version. But when Python actually executes this code, it still treats it as if it was a normal import and normal system, and it'll actually run the command. Even though, again, you just passed their keyword check. And I won't talk about the last one too much, but you have alternate encodings such as UTF-7, which you can use to actually put your entire Python source code in a different encoding to bypass character detection. Okay, cool. All right, these two are incredibly broken and they can solve pretty much every single one of the challenges you'll see on like a beginner to medium level PyJail challenge. So pay close attention to these. We have breakpoint and exact input. If your challenge is just checking for keywords, this will bypass it. As long as breakpoint, exact input aren't in your blacklist, then you can use this to bypass the blacklist. All breakpoint does is it just exits out of your restricted environment, for example, and lets you write whatever code you want there, and same with exact input. So if it's checking for the word system, it looks at your keyword breakpoint doesn't have system in it, so then it lets you write whatever code. So I just recommend you try these two out and it'll make more sense. All right, here's a nice one called getAttr, which does the same thing as the dot operator. So if you're trying to get a property, but you can't actually use the property name like system. If system is blacklisted, you can use getAttr to do the same thing as os.system, except now you can use a string. So you could use any of the methods we use to bypass string detection, like splitting up the string, hex, CHR, all that stuff works with getAttr. The second one's the same thing except using dir, which dir just returns all the attributes on an object as an array of the string names of the attributes. So the 283rd attribute on OS is system. So we're doing getAttr OS system or os.system. And then calling who am I. And yeah, that who am I again could be any shell command. Okay, this is just kind of a joke slide. Just know that, yeah, here's a bad thing you can do with shell, delete their whole hard drive. Okay, so you can see these types of gel challenges in two ways. They might be using eval or exec. Both execute your code, except eval will only take expressions, so one line, whereas exec can take multiple lines. So you might think, oh, I can't do imports if I can't use multiple lines. You can, because Python provides the dunder import function, which basically does the same thing as import, but it returns the module you imported instead of needing a whole new line and just loading it as a local variable. So yeah, same thing. And also you can use globals, which returns a dictionary of all of your global variables. So if you had already imported OS and you want to access it, you can use globals. Again, that's useful because it can be as a string and you can use the string bypass methods.
Yes. So when you use import, that's put into your globals variables that you can then use like in that print function.
Are you talking about if you're using import as like,
Or what did you say is dunder?
yeah, dunder just means double underscore.
Yeah, the underscore import. You use that imports OS to your globals, or does that just import OS to your?
Oh no, sorry. So if you use the normal import, like import space and then the name of the module, that imports it to your global variable. Whereas this just literally, yeah, okay. Well, they're kind of the same, but just know that this dunder import function literally just returns the module.
Just on one. Okay.
Yeah. Not in your locals or globals or anything.
Okay.
Alright, here's a challenge for you guys. So can you think of a way that we can still read flag.txt without having to use single quote or open or read? Okay, you should go next slide. Yeah, I know there's like a bunch. One, two, one. This looks back even like there we go. Okay, so yeah, if anyone wants to answer. There's like
Those are two examples that don't work.
yeah, those both don't work because they have open and read, which you can't use.
I think we go too far.
Yeah.
You could try making it like X encoded. So you don't directly ever use it. So, you know,
Oh, I see what you mean. So you're saying wrap the whole thing in exec and then put like print open blah 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 not read.
but in X, yeah.
In X,
So
yeah.
it won't actually appear with like the slash.
Yep, that would totally work. Any other ideas? It's not the one we wrote down.
Are like double quotes and single quotes banned or just?
Good question. Just that one.
You can just use single quote.
Yep, that's one part, but notice the keyword open is still there, so you have to use something else.
Process.
Sub-processor work. You want to clarify like how would you use systems?
That's one way to do it.
Well, we're asking the dictionary, but that's better instead of just having open, we don't have open plus.
Yep, that worked. Alright, I'm gonna show the one we wrote down. You guys all mentioned subprocess would work, using exactly text would work, using get adder to avoid having to actually put open. That all works and they're all pretty useful. The one we wrote down. Okay. So instead of using popen or open, we use system and then run cat. Yeah, we avoided using open, and instead of using double quotes, we use single quotes. Okay, here's a pretty long cheat sheet, which I already talked about most of the things on here, like under import, dir, globals. I'll talk about subclass class space later, and then already talk about get adder. So the one I want to talk about here is built-ins. So built-ins just stores literally like pretty much everything that's a global variable when you start out in Python. So for instance, int is in the dunder built-in .int. And why you might want to use this is again, if you chain it together with get adder, you can access things without having to actually write out the letters I and T. You can put in a quote, hex encode that quote. Now you avoid having to actually write out things. More useful for things like, I don't know, like import. Because import is a built-in.
Just do space bar.
It's like kind of, I have to like really aim, but it's okay. So yeah, that's just source code limitations. There's also environment limitations, which you'll see an example of right now. Here we go. So the other attributes that are other parameters you can pass to exec, the second and third ones, it goes globals, then locals. So in this example, we limited built-ins to empty dict, which basically means all the built-in stuff that you want to use, like import is a built-in, you can't access anymore. So yeah, that's clear, right? Since built-ins is empty, we can't use import, which means we can't import sys, we can't import OS to do os.system, can't import subprocess, so, and we also can't use open. So all the things that we normally use to read files are blacklisted right now. So we gotta be a little bit more creative. But as you can see, they gave us access to their globals, so. Yeah, come on, so close. I'm just gonna hit space at this point. Okay, one back. Thank you. Okay, so in this case, since they gave us access to globals, globals is just a dictionary of all the global attributes. And since their globals doesn't have the restriction on built-in, we could just access built-in on globals and then go import and do all those stuff around. Yeah. Just to repeat that, globals is a dictionary or a function that returns a dictionary. since they've already called the function when they're giving us globals, we don't need to call it again. We just use it like a normal Python dictionary, getting the element built-ins. You know, built-ins as under import stuff. All right, this one is like super crazy. This sort of stuff you can just memorize, but we're given the print. Yeah. I memorized it for like half of it. Okay, so we're given a print function, which we can use the dunder class attribute, and then dunder base, and then dunder subclasses, which is a function. So I'm gonna just skip. The class is like function or method, something long. And then the base class of that is, oh, I died. The base class of that is literally just object. And then since everything in Python is an object, the subclasses of object is pretty much everything, including built-in importer, which is just a function that lets you, not a function. It's an object that lets you import modules. So we use the function load modules, OS, and then that gives us the OS module. So you can just steal this if you're doing a challenge or something. It'll probably work. Oh yeah, it doesn't actually have to be print here too. If you did like open curly brace, closing curly brace, that's just an object. And then the same thing works. So object has a class, which has a base, which has subclasses, which lets you access load module.
How did you know the index of import was 124?
I checked.
Like you just write everything.
No, what you could do if you're writing this yourself, for example, is like write a for loop that loops over it and then check every single index, that the index is equal to the thing you want, and just return the index.
Is it like guaranteed to be the same on your local?
Yeah, I think it might change on certain Python versions, but usually not.
If the environment is different, the index might change. But if you print out that whole underscore as the classes thing, you can see the full list, figure out what index it's at.
Yeah. Oh, yeah. That's if it's not blind. Sometimes you might get a blind PyJL, which is annoying. No, that's backwards. All right, this is just an example to show you, because I guess PyJL can get from like really easy one-line stuff where the same solution works, like exact input will work for a lot of PyJL challenges. And on the complete other end of that, you have the ridiculous difficulty challenges where you'll be spending hours and hours trying to solve. So here's one of those. So yeah, when Python is executed, it's first compiled to Python bytecode, which is a sort of stack-based assembly language. And then you can actually put restrictions on this Python bytecode at a compiler level, which you can use to make pretty advanced challenges. So this is putting restrictions on like very specific things you could do with the language, such as here's a actual CTF challenge where they don't let you make or call functions. So again, this is editing the actual language itself. They put an input link. You can't use if, else, for, or while. You can't use double underscore, which gets rid of a lot of things. And the only built-in you're given, which again means no import, no open, no any of that stuff, is the gift function that they wrote, which lets you set one attribute. So we're just going to skip straight to the solution because I don't expect anyone to be able to solve this. They just use a tuple in order to get a lambda function, which then they use a attribute called myMethod and set it to itself, because Python is unique where methods and functions are different. And if we go back, the restriction was only placed on function calls, not method calls. So it's kind of a fun way to get around that. Then we set the code attribute and then call it with import. Ask Pete for details. I don't know about this stuff. Okay, if you have any resources, or if you have anything you want to know about, you can Google it. You can look on Hattrix, which has a lot of stuff in the slideshows too. And then while you solve these challenges, also I made a new challenge, so try that if you've already solved all the PyTales or solved most of them. It'll probably be a little bit easier than PyGel 6, so you might want to do that first. Also, a lot of people haven't solved the prairie of learning, which is another PyGel challenge. Next meeting, nothing, it's around fall break, and then after that, we have web hacking 3. Yeah, get excited. Right now, view PyGel, yeah. If you have questions, ask me. I know like all the solutions. I know. I haven't all memorized. I won't tell you, but.